introduced yourself to each other by now, but so why don't you guys introduce yourself to me? I mean, you can just, so let's go with, hey, I see Vani. Vani, I know, I think I'm familiar with
Yeah.
you.
Hi, ma'am. Good morning. How are you?
Yeah, I'm good. So, okay, so next in line, so I don't have you to introduce you. I don't want you to introduce yourself. What about Funny? I see Surampudi Funny Datta.
Good morning, ma'am.
Your name well.
Yeah, it is Surampudi Fanidatta.
Okay, great.
Yeah, I am from Hyderabad. I studied in Christ University, Bangalore. I did my triple majors in economics, political science, and sociology. So yeah, that's it, ma'am.
Great. Next in line is Manasi. Manasi, are you there?
Yes, ma'am, I'm here. Can you hear me?
Yes, I can.
Hi, so I'm Manasi Jayaprakash. I'm from Bangalore, and I did my undergraduate degree from Christ University as well. I studied economics, psychology, and sociology, and that's about it. Yeah. Thank you, ma'am.
What about Simran?
Good morning, ma'am. I'm Simran Agnihotri. I'm from Noida, and I've done my undergrad from Delhi University with my majors in economics and my minors in mathematics. And just yesterday, I finished my final year exams, so I'm final year graduate. And yeah, that's about it.
Yeah. What about what about Sarthak?
Good morning, ma'am. Sarthak here. Am I audible?
Yes, you are.
Yeah. So Sarthak here. I am from Delhi, and I did my undergrad from Bangalore, Narsimhanji Institute of Management Studies, Bangalore. I did B.Sc in economics honors. So yeah, that's about it.
Great. We have Amulya Verma as well. Could you please introduce yourself?
Good morning, ma'am. My name is Amulya Verma. I'm from Bhopal and I did my BA in Economics Honors from the Bhopal School of Social Sciences.
BA in Economics Honors. Oh, great.
Yes, ma'am.
Great. Hi. The next in line to introduce themselves is Moinuddin.
Yes, madam. Hello, ma'am.
Hi, Moinuddin.
Yes, madam. This is Moinuddin Ahmed, and I am from Bhopal, and I have done my undergraduation in physics, chemistry, and mathematics, and yeah, that's it from Jamia Millia Islamia. Yeah.
Great. Tanya, can you unmute and introduce yourself, please?
Good morning, ma'am. I'm Tanya Agarwal. I have done my graduation from IIS University, Jaipur, in economics honors with statistics.
Great to know. Who else? Yeah, Shubham, I think, is left. Shubham, are you there?
Good morning, ma'am.
Good morning.
I'm Shubham Toke. I'm from Indore. I've done my BA Economics Honors from Bhopal School of Social Sciences. My last sem is yet to conclude.
Great. When are they concluding the session for you?
Ma'am, probably by September end.
September end? So you will be joining us late or from the
No,
first?
ma'am, I would be doing that simultaneously.
Okay, great.
Thank you, ma'am.
Have I missed out on anybody? Pranvi, I think.
Yes, ma'am. Good morning, ma'am. Ma'am, I'm Pranvi. I've completed B.Sc Economics from Narsimhanji Institute of Management Studies, Mumbai.
Okay.
And I'm currently residing in Delhi.
Sarla Modi Institute of Economics. I don't know.
Yes, ma'am. Sarla Modi School of Economics.
So Purna Banerjee would have taught you.
No, ma'am. She left before she got we got a chance to study under her.
Yeah, and I think there is Kiran is also still there with
Yeah,
you.
Kiran sir taught us in the last year, and he also left the college like this year with us.
Oh, that I'm not updated yet, but we are all products of the same institution, so pretty much like we have an alumni association which keeps us in the loop. Uh,
Okay.
okay, great. So I think we can. Yeah, I think that's. I think I've gone through the entire list. Great. So we can now start. So the point is before. So I don't know. I mean, I wasn't familiar with the MA admissions process so much, to be honest. So I thought of keeping an introductory session, you know, aligning or trying to understand what you guys, I mean, what your background is, and predominantly explaining how my course in MA economics will proceed. Right. So it's and very often the first thing that any a student encounters is, or the first problem itself is like not being comfortable with the quantitative side of it, which is what you see these days, that math is big or math is being extensively used in this subject. So now the idea over here is that yeah, the idea over here is that that I would like to explain a little bit about the history side, that so that in a way when you start this semester, when you start this course, you should be pretty much convinced that math is something which will help you, and math is something that you have to do, whatever is being taught to you, that you have to do honestly, so that you do well in your MA program and otherwise, right? So no, so this is my way of trying to sort of convince you via his history, via giving you historical examples, or via giving you a historical logic. Again, we are back to the whole um, back to the whole or you can say department, or we are back to the whole department of deduction, which is I give you a logical reason, and you absorb that reason, or you agree with that reason, or you disagree with that reason, and you proceed. So math, for that matter, is mostly about this art of deduction, right? The point is the math that you understand, or that you understand immediately, or would have seen in your undergrad, or you would have seen in your class 12 till class 12 standard, is very number oriented, or is a math wherein you feel that okay, if a person is good at math, he or she must be good at counting, he or she must be good at calculations. But math is not, if anything, math is not that. If you're good at calculation, you're good at accounting perhaps, but math is something wherein the fundamental aspect can be divided or can be understood in two frameworks. First of all, the first is the art of deduction, reducing something. The second is the art of induction, right? And I think, I don't know if you're familiar with the induction and the deduction aspect of mathematics, but I'll explain it in a bit. Now, I'm muting everybody, huh? Because I think there is a noise at the back, right? Uh, Great. So, so what do I mean about math being the art of deduction? Now, when you think of the English language itself pretty much explains what deduction deduction represents. This is where you have a set of assumptions, or you have a circumstantial evidence, say, and you want to deduce something. You want to get to know what what can you conclude from this, right? So this is a way of So this deduction is something that you would have seen in through proofs, theorems, axioms, axiomatization, and this aspect of math is what we understand as the abstract math as well. So there will be you will I mean many a time people will be arguing, okay, when will we use this kind of math? We won't be using this math. Why are we learning it? And blah and so on. But the point over there is you are not learning that particular proof when you are learning the math. You are our job is or our essential aspect behind learning math is that you learn math to be able to learn that art of deduction, to be able to deduce things. Now the other aspect is which is something which is again can be understood as the art of induction. Now, induction for that matter is something that I don't know if you still remember your principles of mathematical induction from your school that you would have seen. The way you've said let a statement be true. So you showed a statement is true for n equal to 0 or n equal to 1. Then you assume that suppose a statement is true for n, and then you showed that the statement is true for n plus 1. So you said hence this statement has to be true for all values of n. So this is something which is called as the principle of mathematical induction, and this has been heavily used I mean as far as I remember the class 12th curriculum, we did it in I think 9 10 or so on. So the idea of this principle is also very interesting. The way the way what it tells you is that instead of coming from a set of assumptions and then deducing what has happened, you look at the circumstance, you look at all the circumstance, how numbers are behaving, right? So induction is something wherein you induct some knowledge out of the smaller examples that you have seen. So in a way, what you would have seen is uh, so that the two aspect can be understood like this. So you see, uh, you find, so your axioms can easily go like like imagine the assumptions of perfect competition market, perfectly competitive market, where the assumptions are there are infinitely many buyers and sellers, and free entry and exit, and homogeneous product, and so on and so forth. You can list out all the assumptions of a perfectly competitive market, right? And then you say, given these assumptions are valid, P equal to MC of firm will be the outcome, which is to say firms will be price takers, right? So the idea over here is firms won't be able to influence price, and hence the competitive price should be seen as an outcome or at the outcome of this kind of a market equilibrium. Now, this kind of analysis is a deduction method. It's did via those assumptions, you have deduced that, deduced your conclusion. The other, when we talk about induction in this particular example will be you look at different markets. You look at different markets, and suppose, I mean, I have taken an assumption wherein the market is sort of like a utopian market, which is not possible. But suppose you are just looking at different markets, and all these markets are, say, examples of perfect competition, wherein you can see that P equal to MC or price equal to marginal cost is deciding the equilibrium price and quantity for you. So if you see these two situations if you see these different markets who are giving you P equal to MC, you generalize a theory. So from bottom to top you go. You generalize a theory and you induce that and you induce this conclusion or not. And the difference between deducing is that you already had assumptions. So you induce this conclusion or a result based on what you have seen happening for many examples. So the difference, why am I highlighting the difference in between these two sides of, of math? See, the idea is math or mathematical theory has to be honest, has mostly become the first part, which is the art of reduction. Think of an equation, very abstract equation. Think of complex numbers for that matter. Do you see complex numbers in real life? The entire complex analysis that you would have worked with, functional analysis. The idea over there is not that in reality whether that math will be visualized or will be experienced. The idea over there is that this is that if I have a set of assumptions, I can from set of assumptions A, I can come to a set of conclusions, say C. So if those assumptions are valid, the conclusion should also be valid and should also be seen. So this kind of deduction is something that math is pretty much now focused on. There is a applied side, and there is and what everybody across the spectrum, be it sciences, social sciences, considers as a valid argument. This is it's a very valid or convincing argument for you that if you see a math which is showing you that showing you Pythagoras theorem, say square of hypotenuse is equal to square of base plus square of perpendicular. So this is just look at this statement for that matter. Pythagoras proved that for all triangles, right angle triangles, this is true. He is not taking every single right angle triangle and trying to do it via calculations. By the way, this was the first method that Greeks used when they wanted to prove Pythagoras theorem. That they took hundreds and thousands of examples of triangles, right angle triangles, of different sizes, different sides, different calculation measurements, and then they saw that this rule was pretty consistent. For a right angle triangle, hypotenuse square will be equal to base square plus perpendicular square. So when they saw this rule, they were like, okay, and this is, by the way, the method of induction that I've been talking about. That when they saw that this kind of rule emerges out of thousands and 10,000s of calculations, they thought perhaps this is a universal truth. But that's not a valid mathematical argument. The valid mathematical argument is that you have x as your x be the length of any perpendicular, y be the length of any base, and let z be the length of any hypotenuse. So your job is to show that z square is equal to x square plus y square. How do you do that? So my point is, this is how you set up the problem. The assumptions first, and then the proof. And that is considered a valid mathematical argument. The induction, not so much. Now, so far good, we have established the difference, and we'll talk about, and that doesn't mean, the point is the way math actually emerged. It didn't really emerge right from the proofs or the reduction part. It actually emerged somewhat from the induction side of the theory. Now think of economics in general. Think of economics. Think of the circumstances where you have been applying math to explain arguments. Utility maximization concept, supply equal to demand concept. If prices increases, price increases, demand goes down, and the point is everywhere whatever math you see in equations, which is sometimes, or you can say there are still people who would criticize the heavy hand use of mathematics and economics and would be arguing that, well, this is a very recent phenomena, and economics, the overuse of mathematics in economics is problematic for the subject as a whole. But this is where I find the argument a little flawed. Because see what happens. So I will tell you I'm giving you a historical evidence. Now the historical evidence goes like this. The way Adam Smith, Ricardo, and even before Adam Smith, the way people understood free trade, understood a very simple example that free trade is beneficial for all of us. This is the statement which has been the driving point of economics, that trade benefits all. So any protectionist measures are criticized on the grounds that there are benefits from trade, right? So anything, every time it's criticized. So any protectionist measure, you'll be called as conservationist, or fascist, and so on. So now the point is, I'm not denying whether it's good or bad. I'm just telling you why people say free trade is the best. Now free trade is the best thing because of the deduction process that happened. So even when people were bartering and they were free to do it, like I will give you 5 oranges if you can give me 1 kg rice. This was maybe a simple barter mechanism. I'll give you 2 kgs oranges if you give me 1 kg rice. If this trade is somewhat restricted, that you can't barter, say a rice seller can't barter with an orange seller. The point is, you can deduce, or people deduce that, oh, if I could just freely give away my product and exchange with the other, I'm so much better off compared to if I don't have direct contact with the orange seller, and I'll exchange with the apple seller, and then the apple seller can exchange with the orange seller, and then I can get. So I am trying to circumvent maybe certain rules that have been set, right, in order to trade commodities. Now the idea over here is that, so anyway, your common sense over there is you're applying to the situation overall, and you're thinking, maybe trading freely is going to benefit us all. Then you come towards the competitive market angle of it, wherein free trade gives you a competitive pricing for a product. Now these kind of arguments have already been made in the books written by Adam Smith, in the books written by David Ricardo. And these were the books written in what, 18th century? These are 18th century books, like late 18th century, but these are very old books which, without using math, have been using this deduction technique. Do you see why we emphasize so much on the deduction aspect now? Because economics inherently, from the 17th or from the 18th century onwards, have been using this deduction reasoning, wherein you understand certain, you understand the situation, understand the circumstances, and then you conclude something, right? So technically, in my opinion, you have already been using the concepts of math. because math is not equations. Math is not calculations. Math is the logical, deductive reasoning. Inductive too, because there are some aspects of inductive reasoning that you will find in economics as well. That you will find like I said, for the Pythagoras theorem, you'll find that once you have inducted a reasoning, you try to come up with a valid proof to support it. So and you will see that there'll be many so in economics, for that matter, my point is that from early 18th century, since the subject has been developed or talked about, or even see, economics is the study of economies and how in different situations, how if we change a certain if a government policy is changed, how the outcome will affect, how that will affect the outcomes of a market, is essentially the study of economics. There's nothing else that you study there. So everything that people have been doing from the 18th century onwards, 17th, 18th century onwards, has been using this deduction technique. Now, what has happened is that with the help of Samuelson, you can say this was the Samuelsonian way of thinking, and it has become that famous because of these two people. One is Samuelson, the other is Arrow, Kenneth Arrow. So I think I think they were two. I think one of. I mean, they were brother-in-laws. So I don't know if Samuelson's sister was married to Arrow or the other way around. But likewise, I mean, they were related. So they were related by law, and so they were, and they are the ones who actually introduced the heavy hand application, or you can say use of equations, symbols or mathematical language in the subject. But the point is, when I'm saying mathematical language, you'll see I'm saying but or people say that since 1940s onwards, the economic subject has been overtaken by this whole Samuelson arrow way of using math to explain concepts. The point is, there was nothing to overtake. My point, at least, is this: the logical deduction was very much part of economics as before in the 18th century as it is now. The only thing is, you have learned to use those techniques, the little details which are taught when you are learning mathematics, those simple formulations or arguments that you have learned to incorporate in the theory, so that you don't waste time writing long sentences, writing long paragraphs, long pages. So something which you can explain in just one equation, but what you're explaining in one equation can be written in a paragraph or in one page, logically deducing, or logic, and both situations will be considered as using math. This is at least how I argue, or at least how I understand the way mathematics has been used in the subject. So from 1947-48 onwards, I think Samuelson developed, showed that you can use very simple math and show that equilibrium, demand supply curves, and you can find the market equilibrium accordingly if there are certain set of assumptions which go through, right? So every model that has been, this whole way of explaining that if so and so happens, then this will happen. This if then kind of a relation, this if then kind of a relation is what essentially was explained using lesser ink. Basically, that is what happened. Otherwise, the explanation was in words, or you can say verbatim, but but without any equations. So this happened so Samuelson showed all this, like, he was used to hang out with physicists, and he got interested in seeing that, it's so easy and so fast, so quick, so much quicker to explain a concept that he's trying to, write a book on. So then he started using using that language. So this is my way of understanding. We say, I understand it like a shorthand. So the way journalists use a shorthand to write a story when they are looking for notes, that's how Samuelson used math in economics. But the story doesn't change. The math doesn't change the story, because the logical or the deduction reasoning has already been applied. So then Arrow published his papers about existence theorems. Essentially, which did finally establish the theory of economics, right? Or especially microeconomics, wherein the question always remained, even though you can see price emerging, or you can see price and quantity at which commodity was sold in markets, you didn't have again, the whole idea was you didn't have a theory which could explain what can happen given certain assumptions are valid. So what can happen for all the markets if they satisfy a particular assumption? Like the same thing, the Pythagoras Theorem argument. So this is something. So Arrow came up with the existence theorems. The only criticism that I agree with is in terms of what Deirdre McCloskey has to say about use of statistics and mathematics in economics. So she's not discrediting use of equations. She is actually discrediting, or she is not comfortable with this deductive reasoning to begin with, which is the work of Adam Smith and Ricardo and so on. So, but that's one of the criticism, and wherein she says that the kind of questions that you mathematicians or mathematical economists, or or even economists in general are bothered with, is that why an equilibrium exists, whether an equilibrium will exist. But they are not bothered with how much, with the how much part of it. How much part? How do you understand how much part? How much part is like, say A will affect B is something there. So is A will affect B, and hence the outcome will be C. But how much will that affect B is something that economists generally are not most interested, especially when it comes to establishing a theory. We are interested in how much through empirical evidence, but not when it comes to establishing the theory, which is again a flawed argument, because you will see that math has been used to show the how much as well, which you will see later on in your course through derivatives, through partial derivatives, through single order derivatives. So the question that you ask or yourself over here is that if am I doing something new? If I'm using equations in my math, in explaining concepts in economics, am I doing something new? And the answer is no, you're not. And any equation, all any equation, or all an equation does in a course in economics is just reduce your typing. You reduce your typing, reduce your ink. You reduce the usage of ink in the syllabus, because this deduction thing is very crucial for economics. So what we are going to do is we are going to look. So this is a very just to give you a brief overview of the mathematical methods that you're going to learn. That course is going to be very what can I say? Very fast-paced in terms of the concepts. So many a times it will happen that I will explain a concept to you, but I will not, tell you that how the deduction or the induction or how the history happened of it. But you have to remember the history is always telling you that unless and until you hone this art of deduction, you are not going to do well in economics. So having assumptions and coming to conclusion is the paramount uh, technique that you should learn from all your quantitative courses. So even when the research goes on like this, by the way. When you are researching, you have to estimate when you are researching, especially the area where I work in, we work in theoretical models. So basically the theory of the subject, you do establish assumptions. You do establish your assumptions and you say, given these assumptions, my results will be an outcome. The result or the theorem that I have given will be true. So, this is what you have to grasp. You're in a master's program wherein eventually the some of you will go for higher research in economics. So the point over there is, don't shy away from the use of math. You're not. Even the econometrics that you are using is going to use math. So you use, first of all, a technique. Econometrics gives you a statistical technique, and then that technique has also been validly proven through proofs and theorems. So we have about 20 minutes left. I will take questions about this whole, about what do you think? I mean, whatever I have told you, what are your thoughts? So I can take questions, comments. Let's have a interactive session. One second. Anyone? I won't take no for an answer, so you'll have to speak up. Should I start cold calling people? Anything. Give us your experience of math. Like, what do you find more? Like, what do you find difficult when you're using, or what do you find easy, or what doesn't really, or what is something that you're not able to really connect? Like anything that you have faced with the usage of math in economics. Okay, so I am starting by names. Moinuddin, do you have any problem? What are give us some comments. Tell us your experience, because you are a physics, chemistry, math undergraduate. Tell us how you got interested in economics and so on. Sorry, you're mute. Unmute yourself.
Yes, ma'am. Can you hear me?
Yes.
Yeah, I have done physics, chemistry, maths in graduation, and I wanted to do economics, but with a talk with Malhotra sir, he told me that since you have no economics background, it is better for you to apply for public policy.
Okay, so you're a public policy student.
Yeah, he told me that economics will not be good for you because it will be very rigorous for you since you have not learned economics at the undergraduate level.
I have a MA, or you can say a M.Sc in mathematics from IIT Kanpur, and then I did my Ph.D. in economics. I ended up doing more math over there, game theory eventually, but the idea is, it does. I mean, if you really want to, then you can, I think, survive on an economics course, because you have already survived physics, chemistry, and math.
Yes.
Okay. So that's not a problem. But okay, so overall, So let's just move on to somebody, because this talk is about math for economists. Let's move on to somebody who is eventually you going to an MA economics program. What about funny?
Uh, yes, ma'am. I did we didn't have a lot of I mean we did have math, but more of a statistics and basics of regression. So that's I'm not well versed in economics and math recently, but I so since I think for macroeconomics, ma'am asked us to learn calculus and all, and I've been learning mathematics over the summer as well, so that I'll be ready when the classes begin. Yeah, I don't have questions though. Like the way you explain induction and deduction and how math is the art of deduction, it makes sense and it was very intuitive.
Good, good. Yeah, so this is what my point is, that you are beginning a course wherein the first thing that you will see is, like, we'll be doing a lot of mathematical concepts, and we will be talking about how something. So there will be times that you will say, "Acha, what is the application of this whole thing in economics?" But my point is, don't worry about it. The application is that whatever you are learning is developing your art of deduction. It's making you develop those skills that are needed for you to go from A to B to C and so on. So you should be able to deduce, not like yeah. So it's a good thing that, and that's the only point that's the one thing, that's the first point to take away from this talk. Manasi, do you have anything to comment?
Yes, ma'am. Can you hear me?
Yes.
So I did mathematical methods in economics in my undergrad, I think in my second year. And I hadn't done math since 10th standard until that course. And honestly, when it was applied to economics, I found it really easy to grasp things like calculus and differentiation and integration. It was actually a lot less intimidating than I thought it would be, and I caught on to it pretty quickly. And it was a really interesting course, and that's what made me more interested in economics actually, and made me want to do a master's in it in the first place. So I find that, yeah, like you said in your your discussion earlier, that the history of math in economics is actually it's a super vital aspect of it, although I wouldn't say that it's vital in within all the concepts in economics. With certain aspects, a more qualitative take on a particular topic is somehow sometimes more beneficial. But yeah, in terms of my difficulty with certain concepts, there are some things that I haven't touched upon in a really long time, like trigonometry, and I don't know how widely that would be used. But yeah, I should. I'm in the process of revising. But yeah.
So good, good, Mansi. Thank you for telling us this. No, so trigonometry is not heavily applied, especially at the level that you are at right now. I mean, so the only way I can see the use of trigonometry is, suppose you have to solve a very complicated
Mm,
integration.
okay.
Integration. But then the chances of having to chances are very slim that you will have to solve a very complex integration problem. So which is why our focus mostly is, so I'm not going to teach you trigonometry. It's not part of the syllabus. Anywhere else, I think in the future ever, in your research or whatever, if you come across an integration, or you can say, if you come across a situation where you're using trigonometry, because it's more useful for students of physics, for students of engineering, than for students of economics, to be honest. So if in case that is the case, then you can always learn, but that's not a but this MA program won't be including trigonometry.
All right, ma'am. Thank you so much. Thank you.
So let's hear from. Let me look at this. Let me scroll. Let's hear from Sarthak.
Yeah, ma'am. Am I audible?
Yes.
Yeah, so ma'am, I did not find maths to be really difficult in terms of when I was studying economics. But if I have to pick a topic off the top of my head, then I would say that I found non-linear constraint optimization a little bit tough for me, like those Kuntaka conditions and all first derivative tests. So I found that a little bit boring, or a little less interesting as compared to the other topics. But it was the overall the subject was pretty much interesting and interrelated with the economics part of it.
Great. Great to know. So this is what the point is, that the math that you're going to learn, and I'm good that Sarthak has brought this point out. I wanted to make this beforehand only also, that the math that you're going to learn is not going to make you researchers in mathematics. Is not
Right,
going to make you mathematicians. It's not. It's just learning the language. It's
right,
treated as learning a language in which your economists are debating right now. So if you want to do well, or if you want to be at a at an advantage or do well in your economics program throughout, uh, learning how to speak or how to formulate arguments in mathematics is going to help
right.
tremendously. Yeah. Vani, do you have anything to add?
Thank you.
Yeah, thank you, Sarkar.
Ma'am, not much, but like, you know what happened last sem. So I mean, yeah, it's what you said in the whole conversation right now. It obviously makes a student start thinking like a student like me who is afraid of all kind of quantitative things. It makes us start to think out of these logical things, and the one that comes out of historical, and to not thematically think about it rather than going to a quantitative side, and that might help us to understand the theory and the concept that goes behind it rather than the numbers and the equations for it. So it can be a little peaceful in the mind thinking about these logics rather than the numbers. So yeah, that's the good part if it's coming ahead.
So if you were able to finish my course, this course would have been very easy for you.
I hope I'm able to finish this one though.
But this is a course. You have to finish it.
Yes, I shall, ma'am.
Yeah. Anyway, so good. I mean, we are well within our time to be able to finish this talk. And unless you have more questions, we can wrap this session up, and I'll see you in the first week of September. Questions? Nope, nope, nope. So yeah. But you can expect this in my class, by the way. I will be forcing you guys to speak. So don't worry about it too much. Okay, so we can wrap this session up. I mean, it was great interacting with you guys. I'm looking forward to, officially starting this semester. And hopefully next semester onwards, we can have you here on campus so that, this whole, I can at least put name to faces. Right now it's just names for me. Great, great. Okay, so great. Nice talking to you guys. I think I'll just stop the recording, and then we can all be on our way. Great. See you guys.
Thank you, ma'am.
Thank you.
Thank you, ma'am.